Hi guys, we're starting today with parent functions. This is just going to be an introduction, and then in the coming days we'll do more with these parent functions. So first of all, what is a parent function? A parent function is the most basic type of graph, and then you can manipulate it after that. So many of you, and you don't need to write any of this now, I'm just going to introduce what a parent function is. Quadratics, you guys know, look like this. That's the parent function. But you guys have seen parabolas or quadratic functions that look like this or like this. There's all kinds of things that can happen to this parent function. The parent function is the basic function with no changes. Okay, so it doesn't get narrow or wider, it doesn't flip upside down, anything like that. The parent function is just the most basic function. So if you don't have this paper, go ahead and pause the video and get it. And let's take some notes together. We're not going to use a calculator for the next couple days, so make sure you're not cheating on that. Here we go. A linear function. You guys have done linear functions. Don't write this one yet, but let's say I have 3x plus 7. Don't write that. We know that that has a y-intercept of 7, a slope of 3. It would look like that. But that isn't the parent function. That's not the most basic type of function for a line. The most basic function without any changes will have 0 for an intercept, which you're not going to see the 0. And it's going to have a slope of 1. That is what I would like you to write. Y equals x, or function notation, f of x equals x. This is the most basic parent function for a line. Now we know how to graph that. We know that it's going to look like this. We could put specific points on there to make our line really accurate. We know it's going to have an intercept of 0, over 1, up 1, over 1, up 1, and so on to make our graph. If you forgot, you could plug in points. So you're not going to do this for a linear function. If I plug in -2 for x, what do I get? -2. If I plug in -1 for x, what do I get? -1. If I plug in 0 and so on, that will give you points to plot. We've already got those plotted, 1, 1, 2, 2, 3, 3, etc. This table is not necessary. It's just in case you forget what the graph looks like. We know what a linear graph looks like, so you don't have to make the table. Quadratic function is x squared. So let's say you forgot what that looks like. Let's make some points. If I plug -2 in for x, what's -2 squared? That's 4. What's -1 squared? +1. What's 0 squared? 1 squared. 2 squared. Plot those points. And connect them. Again, if you know what the quadratic function looks like, the parent function, you don't have to make the table. That's just in case you forget. Cubic function is going to be x cubed. So you might not know what that looks like. Remember, no calculator. Let's go ahead and make our table. Let's start with -2. What's -2 cubed, which is going to be -2 times -2 times -2. Well, -2 times -2 is 4, times -2 is -8. -1 times -1 times -1 is -1. 0 cubed, 1 cubed, 2 cubed. Plot those points. And it's going to get connected to look something like this. Okay. So you should be able to do all of that without a calculator. The more you do it, the more you'll remember. When you hear cubic, you'll know that that's what it's going to look like. Okay, absolute value. Absolute value means distance to 0. So let's make our table. I plug in -2. What is absolute value of -2? How far is -2 from 0? It's 2 away. If I do -1, that has a distance of 1 from 0. Continue filling out the table and plot your points. You could always make more points in your table if you wanted to, but there's no need to do that. That's your absolute value graph. Square root looks like this. You probably don't know offhand what that one looks like, so let's make a table. Make sure you're using a pencil. Because what happens when I take the square root of -2? You can't take the square root of a negative. You're not going to get a real number. So you're not going to get any points there. So I'm actually not going to put negatives in my table. So I'm going to erase that table. That's a bad table. It works well for the first couple, but not for this one. Let's start with 0. What's the square root of 0? 0. What is the square root of 1? 1. What's the square root of 2? I don't know the square root of 2. That's going to be a decimal, and I don't want to graph any decimals. How about 3? I don't know square root of 3. Do I know square root of 4? Yeah, I do. So let's go ahead and jump to 4. Square root of 4 is 2. I don't want 5 or 6 or 7 or 8, but 9 would be a great number to put in for x. Square root of 9 is 3. Our table only goes to 10, so let's just plot those. 0, 0, 1, 1, 4, 2, 9, 3. So the graph's going to look like that. Notice it only has one arrow. It does not continue this direction. We don't have any negatives. The first x value is going to be 0. There's no x values over here. Okay, so be careful with this table that you don't put negatives in. You don't really want to put in 3 or 5. You want to put in numbers that you can easily do without a calculator. You can easily take the square root of 0, 1, 4, and 9 without a calculator. Okay, let's go to cube root. Also, square root could have had a little 2 there, but the 2 is optional because we know it's assumed to be squared. All right, so cube root. Without a calculator, do you know the cube root of -2? I don't, so I'm not going to pick that point. Do I know the cube root of -8? I do. So that's what times what times what equals -8. -2 times -2 times -2 is -8. So the cube root of -8 is -2. Another x value I could put in there is 1. What multiplied by itself 3 times is going to give you 1? Oh, sorry, -1. That would be -1 times -1 times -1 is going to be -1. I can also do the cube root of 0 without a calculator. That's going to be 0. Cube root of 1 is 1. And what other number do you think I could put in there? 8. What times what times what gets you 8? 2. So the cube root of 8 is 2. You'll notice that this table here and this table here, those are inverses. Notice -2, -8, -8, -2. 8, 2, 2, 8. That will happen when they're inverses. Let's go ahead and plot these points. So if this table was hard for you, do this table and then flip the x's and the y's. Notice if I flip every x and y, it will make this table over here. Okay, so that's our first 6 parent functions. You should be pretty confident on doing these without a calculator. Again, if you remember what they look like, you could sketch it without the table. You should be confident with linear, quadratic, pretty confident with cubic. Maybe the other ones you might have to make the table. Let's continue with 3 more. We're actually not going to do this one yet. We're going to learn that maybe second semester. We're going to go over that one because it's much different. Actually, I think logs we're also going to, yeah, logs we're also going to go over in a different section. So not today. So let's go with exponential. So that would be, go ahead and write a b to the x. Now there's a lot of different exponential functions, parent functions. For example, you could have 5 to the x, 6 to the x, 10 to the x. All of these are different parent functions. Whereas in these first 6 that we did, there was only one. This is the only quadratic parent function. But with exponential, it depends what the base of the exponent is. So go ahead and you can erase that. We'll just put an example. Let's put 5 to the x. So for a function like this, you can go ahead and do the -2, -1, 0, 1, 2. Let's start with an easy one like 0. What is 5 to the 0 power? Well, anything to the 0 power is 1. What is 5 to the first? 5. What is 5 to the second? 25. That won't fit on our graph, but we'll leave it there for now. Now let's talk about 5 to the -2nd. If you remember back in Algebra 1, you learned this. If you have a negative exponent, what you can do is you can move that to the denominator and make it a positive exponent. These are the same things. If you want to grab a calculator to check it, you can type in 5 to the -2nd, type 1 over 5 to the +2nd power, you'll get the same thing. Now, we're not allowed to use a calculator, so without a calculator, what is 5 squared? 25. So just write 1 over 25. How about what is 5 to the -1st? Well, that's the same as 1 over 5 to the 1st. 5 to the 1st is 5, so that would be 1/5. Now let's look at plotting these. Over -2, up 1/25. That's not very much. Over -1, up 1/5. Still not up very much. Over 0, up 1. Over 1, up 5. Over 2, up. It's going to be way up there. You don't really need to graph it. Your graph's going to end up looking like this. Okay. And again, for exponentials, the base can be different. So I could have 5 to the x, I could have a different parent function of 6 to the x or 7 to the x. There's a bunch of different parent functions you could do. We are skipping logarithmic. We are actually going to do rational. So rational is 1 over x. Let's make a table. Okay, plug in -2. 1 over -2 is just -1/2. I prefer to put the negative out front instead of in the denominator, but technically it can be in the denominator. Plug in a -1. That's just going to be -1. Plug in 0. What's 1 divided by 0? We can't divide by 0, so I'm just going to put an x. We're not going to have a point there. Plug in 1. Plug in 2. Okay, let's plot those points. Now you probably have not seen a graph like this before, but here's actually how you're going to connect it. Okay, so it's actually kind of in two parts, but it's still one graph. So there's going to be what's called an asymptote here and here, which you don't have to worry about right now. So these may seem overwhelming because they're all different, but the moral of the story is if you can plug in a number, if you can plug in any number, you can make a graph. So for today, all I care about is, can you make these 8 parent functions without a calculator? So if you remember what the function looks like, you should be able to plug in any number. So remember x cubed, and cube root kind of looks like the square root, only it has a 3 here. Absolute value you've studied before. These are going to be the hardest ones to remember. Exponential, pick any number you want, preferably a smaller number, and non-negative, and then make the exponent x. And then rational, you'll have to remember, is 1 over x. Once you have the function, it should be fairly easy to plug in a set of numbers. Okay, so for tonight, just study these parent functions. And if your paper, if this note paper is really a mess and you did a lot of scratch work, maybe print out a new one and make it really nice and neat so you have it for a long time. All right, go ahead and study those parent functions tonight.